Next, let us solve system of equation. So for example, you have two equations in a system. So we can solve this by using simultaneous equation. You can use either substitution or elimination method. For example, here you have two equations, and then we want to solve the system of equation, which is we want to find out x and y, and we want to write it in terms of coordinate later on. So now let's see, this is not the same, so we want to eliminate. Okay, let's use elimination. So this is x, this is 2x. So from equation 1, we need to multiply all by 2 so that this 2x and 2x here is equal to each other. So this will become 2x plus 6y equal to -2, and then just write back equation 2. Now we can do elimination. Just take this equation minus this equation here. So we'll get 7y equal to -7. So just solve for y is equal to -1. So when you got this, let's just back substitute y equal to -1 in equation number 1. Okay, so this is x plus 3 -1 equal to -1, and then just solve for x here. So x is equal to 2. Therefore, our answer xy in coordinate system is 2, -1. Whenever we can solve a system of equation like this and you find one solution, this is a unique solution. So this shows that this is a consistent system and also independent system. If you want to see this in terms of graph, so both of them are straight lines and they intersect at one point, and that point is 2, -1. Now let's see another equation here. Okay, as usual, we want to use simultaneous equation. So this is 3x, this is 6x, so we need to take equation 1 and multiply to 2. And then let's rewrite equation number 2 and then minus equation 1 with equation 2. So minus this is equal to 0. Y also 2y minus 2y is also 0. So 0 is equal to 12 minus 12 is again 0. So when we got equation of 0 equal to 0, this statement is correct, right? So when this statement is correct, 0 is equal to 0. Therefore, straight away, we can write this as having infinitely many solutions. So this is not a unique solution. This is infinitely many solutions, meaning that this is a consistent system. However, it is not independent as just now. This is a dependent system. So how can we solve this type of equation? We can just take one of the variable, let's say we take y, and then write it as y equal to t. Okay, let's take one variable of t here, where t is any real number. And then let's take equation 1 and then substitute your y with t. Okay, then let's solve for x. So x is equal to 6 minus t over 3. You just assign the value of t. For example, t is equal to 0. So the answer is 6 minus 0 over 3, 0. So this is 2, 0. You can take also t equal to 1. So the answer is 5 over 3, 1. Or you can take t equal to 2. So it becomes 4 over 3, 2. So each and every coordinate here, it can be the answer to these equations. So we can write our answer xy in terms of coordinates. Your x is 6 minus t over 3. Your y is equal to t. So what happened here is y is this infinitely many solution, because when you multiply 2 to equation number 1, you can see that these equations are the same. Okay, so it coincides with each other like this. So each and every part of this line here is a solution. So this is infinitely many solutions. So you can just write our answer like this. However, if you want to take out a few of coordinates, you can do that. So each and every number of t that you assign can be found a coordinate there, because this is infinitely many solutions. We can have another case here, which is no solution. Okay, so what's the meaning of no solution? Meaning that this system is inconsistent. Let me show you how can you get a no solution here. So you are given two equations, so we need to solve this system of equation. So let's see, we want to eliminate x variable here. This is 3x, this is 6x. So let's multiply the first equation here with 2. So we'll get 6x plus 2y equal to 12. And the second equation is 6x plus 2y equal to 20. So now let's eliminate the first x here. So let's take equation 1 minus equation 2. So 6x minus 6x is 0. 2y minus 2y is also 0. So your left hand side is 0. Equal to 12 minus 20 is negative 8. So let's see this statement here. 0 is equal to minus 8. So this is not equal. You cannot have 0 equal to negative 8. So meaning that this case here is no solution. So let's just write it as no solution, inconsistent system. So what actually happened is both of the lines here are parallel to each other, so you cannot find any intersection or any solution.